Now we're going to expand these logarithms. So that's each variable or its number is going to get its own log. So log 3 of ab squared. Well, the ab squared's in parentheses, so this is really going to be the log 3 of a squared b squared, which is going to become the log 3 of a squared multiplication becomes addition log 3 of b squared. And my exponents become coefficients. So 2 log 3 of a plus 2 log 3 of b. Okay. In number 42, we have a 2, a b, an a, and a c. So we're going to have 4 separate logs. Now the a and c are both getting the 5th power here. So I have ln of 2 plus ln of b cubed. Now anything in the denominator is going to be subtraction. Ln of a to the 5th minus ln of c to the 5th. And then all my exponents can become coefficients. So the 3 goes in front, 3 ln b minus 5 ln a minus 5 ln c. So everything that was in the denominator here is going to go and have a negative for everything in the bottom. And then number 43, we're going to have a different log for the x and a different log for the y. The exponent doesn't count as a separate number. So we have log 3 of x plus, that's multiplication, so it becomes addition, log 3 of y cubed, and log 3 of x plus 3 log 3 of y. Doesn't want to write. So every number gets its own log. Exponents don't count. Now condense into a single log. Anything a subtraction is going to become division, so it's going to go in the bottom. So those subtractions, both of those are going to go in the bottom. This is plus, so it's going to go in the top. And this is minus, so it's going to go in the bottom of one big fraction. So I have the log of x to the 4th minus what? My coefficients are going to become exponents. So 1/2, so log y to the 1/2, and log of z to the 5th. Now, like I said, we're going to put the x to the 4th in the top, x to the 4th, and both the y and the z are going to go in the bottom because they're both subtraction. Y to the 1/2, z to the 5th. And that's my single log. Okay, notice the word log. It's only there one time. Okay. So I have 2 ln a. The 2 is going to go to my exponent. The 1/3 becomes an exponent. Now this could also, backtracking to number 44, you could also write that as the square root of y instead of y to the 1/2. So I have ln of a squared plus ln of b to the 1/3 minus ln of c to the 6th. So the a and the b are positive logs. They're going to go in the top. So ln of a squared, and I could write that as cube root b, or you could leave it as b to the 1/3. And the c is minus, so it's going to go in the bottom over c to the 6th. 6 doesn't look quite like 6. Okay, number 46. This is going to go to the bottom, but the c is going to go in the top because it's positive. And my 5 and 3 become exponents. So log of a cubed minus log of b cubed, log of a to the 5th. Log of a to the 5th minus log of b cubed plus log of c. Big log with a fraction. A to the 5th and c go in top because they're positive, and b cubed goes in the bottom. Now I'm going to zoom in quite a bit on these so I have some space to write a little bit smaller. So if I have log of a plus 6 minus log of 5 less than log of 2. So I'm going to condense. Whenever I have more than one log on one side of the equal sign, I need to condense them into one log, just like we were doing. So this is the log of a plus 6 over 5. Remember, subtraction means it goes in the bottom. That's division. And that equals the log of 2, right? Now, I have the log equals a log, and so I can set them equal to each other. A plus 6 over 5 equals 2. Multiply by 5. So a plus 6 equals, and now I'm multiplying by 5, 10. So that cancels, minus 6. And a is less than 4. Sorry, my equal sign became, or my less than became an equal sign all of a sudden. Now, when I have a less than inequality as my answer, I need to look at the domain. The only log that has a variable in it is a plus 6, and that has to be greater than 0. So a has to be greater than negative 6. And so we put that domain restriction as a between statement with our answer. So negative 6 is less than a, which is less than 4. Now, if you have two domain restrictions, you take the bigger number first, because that's the first number it's going to be undefined with. Number 48. Remember that ln is log base e. So e goes to the other side. So 5x minus 2 equals e to the 7th. And then we can add 2. 5x equals e to the 7th plus 2. Divide by 5. My exact answer is 5x equals e to the 7th plus 2 divided by 5. My approximate answer, put it in the calculator. We go e to the 7th plus 2. I'm going to hit in your calculator, if it goes like this, e and opens parentheses, you need to type in your 7 and close the parentheses. Then you have to hit plus 2. Then you need to hit equal. If not, if you wanted to do as one big thing, you need parentheses around the whole numerator before you divide by the 5. You should get 219.73. And this is your approximate answer. Okay, number 49. I have more than one log on this side here, so I'm going to condense. Addition becomes multiplication. So it's the log base 2 of 7 times 2n minus 4 equals 6. That's the log base 2 of 14n minus 28 equals 6. Now I can't just get rid of the log. The 2 becomes the base, so 2 to the 6th power. So 14n minus 28 equals 2 to the 6th power, which is 64. I can add 28. 14n is equal to 92. +4 plus 28 divided by 14 is n is equal to 92, 46 over 7. Just going to reduce that. It's approximately 6.57. Okay, now let me show you another way to get rid of the log. Log base 2 of 14n minus 28 equals 6. I know some of you like the exponentiation method, where I say, okay, this is base 2, so 2 to this power equals 2 to the 6th power, right? And the 2 and the log 2 cancel, and we get 14n minus 28, and then we don't forget to put the 2 on that side. So some of you like this way. I end up with the same equation in the end, as long as I do my exponent correctly. Number 50, exponential equations. Okay, we can do the log base, we can do the log of both sides. We're going to rewrite this one as a log first. So the base of my power becomes the base of the log. So log base 1.56 of 8 equals t. And then we use the change of base formula. This can be my exact answer, but change of base allows me to put it in the calculator. Log of 8 divided by the log of the base, 1.56, equals your t. And in the calculator, log of 8, close those parentheses, divided by log of 1.56. T is approximately 4.68. Now, what does the other way look like? 8 equals 1.56 to the t. I'm going to do the log of 8. Log of 1.56 to the t. The t goes out front, so t log 1.56 equals the log of 8. And we're using log 10 here, or you could use ln, because it's already ready for the calculator. Log of 1.56. So t is equal to the log of 8, log of 1.56. You choose your method. Which one makes more sense to you? Okay, I get the same answer in the end. Number 51. 60 equals 120 e to the negative 0.003t. I need to get the e part by itself. So we're going to divide by 120. And I have 1/2 equals e to the negative 0.003t. And e becomes ln, right? So if we do ln of this side, let me just rewrite the whole thing. Ln of 1/2 equals ln of e to the 0.003t. If you're doing ln of both sides, you got to keep the e in here for now. This goes out front, and ln of e is 1. So we get negative 0.003t equals a natural log of 1/2. And then we divide by negative 0.003. And so t is equal to the natural log of 0.5 over negative 0.003. Sometimes it's easier to just put the decimal in the calculator. So the natural log of 0.5, close the parentheses, divided by negative 0.003. And we get t is approximately 231.05. Okay, number 52, we're going to isolate the e again, so we're going to add 6. 3e to the negative 7x equals 24. Divided by 3, e to the negative 7x equals 8. Now we'll do ln of both sides. Ln of e to the negative 7x, ln of 8. Or we rewrite it as a log. Negative 7x equals ln of 8. I'm going to end up with the same thing. Ln of e cancel, right? So negative 7x equals ln of 8. And we're dividing by negative 7. X is ln of 8 over negative 7. Again, remember when you plug it in the calculator to close the parentheses after the 8. And x is approximately negative 0.297 or 0.3. If it said round to the hundredths, then it's 0.30. All right, and here's the doozy problem. This is the one where we're gonna do log base 10 of both sides, and we have to, our step 1 was log both sides. So log of 5 to the 2x equals log of 4 to the x plus 7. Then 2, we use our power property, which is exponents out front. So my exponents go in front. Okay, don't leave them behind. Then it looks like they're in the log. We put them in front of the word log. 2x times the log of 5 equals x plus 7. Don't forget those parentheses. Log of 4. Step 3 is to distribute. We're distributing the log. I don't distribute to 2x, there's no plus sign, so 2x log 5 stays on this side. And I distribute the log 4 to x, so x log 4 plus 7 log 4. Okay, we distribute it to both the x and the 7. And then step 4, we're going to get variables on one side. Which means I'm going to subtract x log 4. So we have 2x log 5 minus x log 4 equals 7 log of 4. And then step 5 is to factor out the x. X times 2 log 5 minus log of 4 equals 7 log of 4. You know how you get good at doing these? You practice a bunch of them. You go back and do the ones that were on the worksheet 37, homework 37. You do them again and again, and you remember how. You train your brain. Divided by 2 log 5 minus log of 4. And the last step, 6, divide to isolate x. So my answer, x equals 2 log of 5, oops, that's wrong. X equals 7 log of 4 over 2 log 5 minus log of 4. And then we have to be able to get this decimal correctly. Okay, so we're going to, in parentheses, in our calculator, we're going to do parentheses. And your calculator usually opens that parentheses, so you're going to close it, and then you're going to put a second parentheses. Then you're going to open parentheses in front of the 2, and then it'll give you these parentheses, and then you're going to close it afterwards. That's how you're going to make sure you get the right answer. So 7 log 4 divided by this extra parentheses there is the most important one, and that's the second most. 2 log 5 minus log 4. I have x is approximately 5.295, which makes it 5.30. Okay, so it's all about the parentheses when you're putting it in your calculator. So make sure you can get that correct answer out of the, okay. Oh, looks like I skipped number 53. So we'll do that one. So this one I'm going to rewrite as a log. Let's try that one. X plus 4 equals log base 2 of 3. And then minus the 4. X equals log base 2 of 3 minus 4. I cannot subtract that. Okay, I have to leave it as 3 and then minus 4. Because in the calculator, I'm going to do log 3 divided by log 2. And then I'm going to subtract the 4. Which is not the same thing as subtracting the 3 and the 4. So log 3 divided by log 2 minus the 4, and x is approximately negative 2.42. Okay, and the last set. Solve an equation, show all work, no guessing and checking. An old classic car was purchased new for $15,000. It appreciated exponentially at a rate of 15% per year. Write a model and then find the value of the classic car after 7 years. So the equation starts its growth because it's appreciating, that means it's growing, as y equals a times 1 plus r to the t. We are not compounding anything, so we are not using the compound interest formula. So y is equal to 15,000 times 1 plus 0.15 to the t. This is the model. The model is the equation. I could also write that as 1.15 to the t. Then I'm going to plug in 7. y equals 15,000 times 1.15 to the 7th power. And plug it in the calculator. And I get 39,900.30. It's 298, which rounds to 30. Okay. Now, the EHS farm had 140 chickens on the first day of school, and the number of chickens are depreciating exponentially at a rate of 6% each month. How many months will it take to have 40 chickens left? So we're using a similar equation, but since it's depreciating, it's 1 minus r to the t. So my model is y equals, even though it doesn't ask for it, 140 times 1 minus 0.06, don't forget to move that decimal twice, to the t. And I want to know when y is equal to 40. So 40 equals 140 times 0.94 to the t, 1 minus 0.06, 0.94. And to solve that, we're going to divide by 140. So 40 over 140 equals 0.94 to the t. I'm going to do that on my calculator. I get 0.2857 equals 0.94 to the t. And I'm going to do the log of both sides. And so the log of 0.2857 equals t times the log of 0.94. We'll divide by the log of 0.94. So we get t equals log 0.2857 divided by log 0.94. And so t equals 20.25 months. Okay. And the last word problem. 60 organisms were placed in a petri dish. The amount A of organisms present in t days can be modeled by A equals 60e to the negative 0.0032 t. After how many days will the petri dish only have 10 organisms left? So we're plugging 10 in for A. 10 equals 60, E negative 0.0032 t. Divide by 60, and that's 1/6 equals E to the negative 0.0032 t. I'm going to do ln, both sides. Now, could you rewrite that as a log? Sure. ln of 1/6 equals negative 0.0032 t. I'm going to end up with the same result. So ln of 1/6 equals negative 0.0032 t. And we're going to divide by negative 0.0032. And I'm going to keep it as 1/6 so I have a more accurate answer, because that's a decimal that repeats. So t is ln of 1 divided by 6, close the parentheses, 0.0032. T is approximately 559.92 days. Okay. So these word problems are very similar to the 3-word problems you were going to have on the test. These equations are very similar to the equations you're going to have on the test. Okay, so study them and make sure you know how to solve them all. The only thing that's not on Wheelock and Olson's test that is not on this is rewriting the inverse and graphing. We'll go over that in class.